So, like Andrew mentioned, we did this last night, and we really started just having everybody kind of give their own little pieces of the story and puzzle, and I think it was a very helpful format. So, please don't be shy. So real quick, as we're walking into this, Andrew mentioned what Redis is, and if you aren't familiar, is anybody not familiar with Redis? Okay. So the biggest thing, have you heard of Memcache?
More or less.
Okay. So the biggest thing that a lot of people, when they read these words, that doesn't necessarily sink in is in memory. So the idea is that it's light and fast in comparison, right, to your traditional and even non-traditional newer databases. So it's just it's a bit of a different approach. Redis Labs has since around July, August has taken on the open source project. So we're the official sponsor for the Redis open source. And even before that, our team of Redis Labs developers has been one of the top contributors to the open source project. So outside of Salvatore Sanfilippo, who actually created it, our guys have consistently been one of the top contributors. And our company's been around for a while. I'm not going to go into all that. But we are very much dedicated to the open source product. We also have our own product that uses the open source, and you can think of it as having an envelope around it. So we have other functionality that's been added, the exact same model as the Red Hat model there. So I'm not going to talk too long, especially in a room full of people that already are relatively familiar with Redis. So I'm going to go real quick. This is a quote I think everybody's heard before by Eleanor Roosevelt, right? So 5 years ago, Amazon found that every 100 milliseconds of latency costs them 1% of their sales, right? So speed is critical to business, critical to every business. Google recently published a statistic that a half-second increase in their search latency dropped their traffic by 20%, right? So the key is we need things to operate at the fastest availability for the most important functions as possible, right? And so in a typical web transaction, what we're seeing now is the standard for any EDE application response time is 100 milliseconds under load. So that gives you about 50 milliseconds to get to the web server because you've got the network involved, right? And it was actually, I think it was about 6 or 7 years ago, Bill Gates said that we're going to get to a point where it's going to take backhoes to increase the speed of the internet. I think we're getting closer and closer, right? And so you're seeing Google Fiber and some other solutions come out to try and speed these transactions to make them faster. But you still have the transaction time within your data center, and this is really where the most control is, right? So people are hammering on you guys that are doing app dev and hammering on the operations people to make sure that they're scaling the applications appropriately. And what you end up with is around a millisecond of time for responses in accessing data based on the number of transactions, the number of requests that your application might be making to the database. And so what that ends up doing is really squeezing the old database technology, right? So this is the internet a long time ago. Now we've got billions of users. So it used to be millions of users 5 years ago. Now we've got billions of users. And we're really talking about Internet of Things, mobile users. We've got a big data problem now, right? Everybody knows this. So your choices are speed or utility, right? In most cases. So if you think about a combustion engine, you can have it go really fast, or you can carry the groceries, right? the Toyota Corolla is the most popular selling car of all time. It outpaced the Model T about 5 or 10 years ago. And the reason why is because, you know, as everybody really wants to go fast, you still have to take things with you, right? So to rethink this model and draw a parallel, in order to get both speed and utility, you have to rethink from the beginning what your database is doing. So most people, when I say database, they think about something like this. They start thinking relations and ACID and the idea of an old world system, a database that was created in theory in the 70s by IBM and Ted Codd, right? This is what we've done to those things, right? The theory is still strong, and there's a lot of value to a relational database, but there's a lot of things that we're trying to do now because of that big data, because the demands are different, because we're trying to get more speed out of it, and it's hamstrung by its original concepts, right? And so if we say, well, the technology that I choose has to be ACID. It has to be highly available at all times. I can't have, you know, my transactions have to be atomic. It has to follow, you know, all of the pieces of the CAP theorem. And I'm not going to go into that because I would get it all wrong. But you know, the idea is that we have to kind of start over with a new concept, right? And so we know about relational databases. Those make sense. There's distributed hierarchical databases like Hadoop that came out as one of the, you know, I guess about 7 or 8 years ago to try and solve this problem for Google and some of the bigger companies. And then there's another category, which are the NoSQL databases. And there's, you know, the different types of those that help kind of categorize them. You know, when I first read that NoSQL was not only SQL, and that's where the origination of the idea came from, I was like, so does that make my chair NoSQL? You know, but it's a definition that describes what it's not as much as what it is, right? So there's different types, and of those types, key value, graph, column, the Redis is the key value type, right? So it's a NoSQL database, but it's also in memory, and that makes it somewhat unique in that space. So, and the thing about Redis that I really want everybody to kind of take away is that while it can be a persistent storage, most people aren't doing that today. If you were doing that, you'd be kind of in the rare category, but it's very complementary to any other data store that's out there. So it can add value to existing relational databases. Madhu will talk a little bit about that. It can add value to your Hadoop instances to help do things to get answers out quicker. It can add value to you know, Mongo or some of the document stores. So I'm not going to go into all of the other types of different NoSQL, but I think it's worth mentioning there's a lot of this out there. And so I think especially the kind of old curmudgeon-y tech geeks are very hesitant to pick a path and take off on anything NoSQL because there's so many options available. I think it's worth mentioning that G2 Crowd and DB engines and a lot of the research in the space is really showing that the key value and NoSQL spaces are part of the biggest growth sectors in the database market today, and Redis is gaining in popularity. And just by fact that you guys, for the most part, all raise your hand, I think that's a testament to that, right? So we can safely agree that this is going to be a technology that's going to be around and with us until something even cooler comes around, right? So we feel confident that it's not going to be, you know, here today, gone tomorrow. So does anybody have any questions about why this is important? I didn't think so. Then I will take my leave and let the smart guy tell you guys what he knows. You know a lot.
Well, again, my name is Madhu. Have, I think, 18 years of experience. I've been a DBA in the past. Started a company when I was in college. Did a lot of software coding, and and living in India comes with a lot of pressure. You cannot start a job. You have to go work for somebody. So I kind of quit that. Started working. So I've been in India for a long time. I've worked on SAP, worked on Oracle, worked on my MS SQL, and then switched to NoSQL. So that's been my experience. I've been working with Redis for almost a year now. I don't have 18 years of experience with Redis. Definitely. And when somebody say, wow, I'm like, no. Redis wasn't there 18 years ago. But I know all of you actually know that how many years? 7 years to go in mine, experience for mine. I know a lot of you actually look at your hands for using Redis. What do you use Redis for, if you don't mind me asking?
Background routes, managing background routes with either or we're using Sidekick right now.
Okay. Background jobs.
Yeah.
Okay. Pretty much. Same thing.
Caching communication data on fly to then classify and store it.
Okay. And is that just a sum of records, or are you actually storing data?
It's a complement of some of the other third-party services that we're using, Pusher, PubNow, something like that.
But you're not storing any data in Redis. Anything else?
I use the PubSub.
PubSub. What are you using PubSub for?
For PubSub.
Are you creating anything else, or?
I mean, most of the data is stored in Mongo,
Okay.
and PubSub just to propagate events between multiple instances of an application server.
Okay. So none of you are using anything beyond PubSub, caching, and that's pretty much it.
I've used it in a database context as a database for a PHP application. Worked flawlessly. I mean, like I was able to scale it to two nodes, or 2 Redis nodes, but I also use it as a caching layer for user profile data, like high frequently accessed data, like stored in Redis.
Okay.
But yeah, so far around those.
2 nodes, how many nodes? How many nodes do you want? One instance.
Yep.
And same thing. And with the PubSub, how many nodes do you use? How big is your deployment?
Just, I guess, I don't know what it's involved in. 0.5 recently is a couple of nodes.
Right.
Yeah.
All right. So, all right. For the rest of you, any idea about Redis? Have you worked with Redis? Do you know how it works? Because depending on that, I can either go into basics or I talk about some of the advanced stuff. So that's why I'm asking that question.
Advanced.
Advanced. Well, advanced would be primarily around the clustering, replication, persistence. All right.
I would just start heading into the advanced, and if anybody has any questions or feel like it's going too fast, and shout out, and we can adjust.
So just a quick background again. It's been covered twice already. Data structure, store, advanced key value, something like this. For those of you who haven't played with Redis yet, if you have played with the regular database, again, this is not the commands for Redis. This is a regular database command, but this is how it would translate to. This is what is a key, the K and the V, and you have a value. That's it. All you need to define is a K and a V. You don't have to have 10 lines of code to define a key within Redis. That's the cool thing about Redis. The second big thing is the data types. If you work with databases, then for all intents and purposes, there's only one data type. Everything is a table, right? Everything else evolves from a table. You can store data in a table, and then you evolve it into a view. You can use views, but it's still goes to a table. Here you have 6 data types, 160 commands. It's super fast. It's a Tesla. We don't call it Ferrari anymore. And it can be used by every. Most of the codes that are out there, most of them have a plugin for Redis, and it pretty much reduces the code by several lines. Right? I'm sure if you've already done a lot of coding, we actually did that with a regular database as opposed to Redis. It reduces your code greatly. created by Salvatore. You can download Redis on GitHub. Website is redis.com. Question? For me personally, this is why I like Redis. It's simple. I can go ahead. I don't have to design a database. That's the other key thing about Redis is you don't have to sit down and design how your database would look like, unlike you would do for Oracle or MS SQL. Right? You need to know what the table is going to be, how the index is going to be stored, what's the primary key, what's the foreign key. Now that is required. All you need to do is just go ahead and start writing code and creating keys. Performance easily serves about 100,000 operations per second. I don't know if this is important to you or not, but in our testing, I have a slide towards the end. We actually have been able to achieve over 1 million operations per second with a sub-millisecond latency. And going back to the latency slide we had, think about 100 milliseconds for a customer. And often, if you look at the research, most people, I cannot wait 100 milliseconds when I'm on an Uber app. Think about it. I'm not going to do that, right? I need to know whether my cab is really fast. So we've been able to achieve over 1 million transactions a second with sub-millisecond latency. Lightweight, if you have already installed it, very small, 2 MB. And it's production proven, except for the new technology. We can talk about that. Twitter, Pinterest, Uber, Flickr, Snapchat, MSN, Outkill, a lot of companies. You've heard this, so I'm going to go past this. And you're the only one using persistence, right? How many of you know about Redis persistence? Okay, anybody else? So one of the biggest questions when Redis came out was, great, this can be used for caching. Great, I'll store this, it makes it super fast, I can store data, and then the second most important feature that people think of is PubSub. But off late, what's happening is people want to start storing data, right? That's what is persistent, the ability to actually make that your system of records. So you can use it in 2 ways. One, in tandem with a Mongo, in tandem with the backend MS SQL. I've seen a lot of people use it in MySQL, Oracle also. In fact, we just deployed for the backend for SAP. So you could use it in tandem with the backend database, or you could use it completely by itself, right? So that's what persistence is, the ability to write to a file. So this is basically how does Redis do that. There are 2 ways it does that, RDB and AOF. So I'll expand that. AOF is append-only file, which is basically a complete backup. The first time you say, okay, I want to take it back, right? It dumps the entire data to this, and then every write you make is going to get recorded to this. RDB is a snapshot. It's like you're just taking, what's that? Image. Okay, whatever. So you're taking a point in time, you're taking a backup of that image, right? It could be every 4 hours, every 6 hours, whatever. So the idea here is since Redis works in the memory, in case the system fails, in case you have to reboot, something happens, you lose all the data. So that's why if it's going to be a system of records, you need to start writing data to this. Okay? However, again, I'll cover about this in a second, but however, the challenge is Redis is works great with memory, so it's all accessing in memory, serving data in memory. Once you start writing it to disk, that could be your choke point, depending on how many writes you're making. Right? If you're writing a lot of data, like today I was talking to somebody, they actually want to write 1 million writes a second. Not reads, 1 million writes. They have only about 10,000 reads a second. So once you start doing that, imagine the kind of overhead. See, again, you're limited by the disk. The amount of I/O it's going to provide, it's going to perform. So that is a big problem. So typically with open source Redis, what happens is once you start exceeding a certain point, it's going to hold all your transactions till it actually finishes writing this. Okay? Questions? If you don't want me to cover, just let me know. Okay? So these are the 2 different types. You have the RDB format, AL format. This is the command and the configuration file. I'm sure if you played with Redis, you have seen this, how frequently you want to save this. With the append-only file, you're going to do it every second. So, as I said, one of the challenges is when you're starting to write to the map. So when you're starting to write to the disk, so every Redis instance has something called a shard, right? A master shard. What happens is if you are having too many writes, it's going to hold up your performance, it's going to affect your application. So to offset that, again, this is the wrapper we were talking about. To offset that, what we have done is we actually create a slave. We always write off a slave. We never write out the master. So the master will always replicate the slave. The replication always happens in the memory. So there's no effect, there's no performance that's being affected either in the master shard or the slave shard. And the slave will start writing the disk, which is a much easier way without affecting your actual performance. That's just one thing that changes down the line. So, questions? Do you have separate people take care of your Redis instance, or do you guys take care of it yourself? DBA or you take care of it?
No, we're doing it.
No. Have you ever,
It'd be nice to have like a outline for scalability, out of scale kind of a,
yes.
yeah.
Next one. Great, I'm glad. I want people to ask me questions. I don't want to sit down here and just show you, this is how you write a command. That's, you can get that from the documentation too. I don't want to be the one trying to show you how to do it. But what I think is based on different customers and interacting with different customers, I know how they're implemented, what they're doing, how they solve some problems, right? So Redis replication, this is the other piece. So typically what you start using open source, and the moment you start using open source, you set up a master. You set up a master, a shard using the configuration file, you're all good. But the thing is you need to be able to, this part of high availability. Right? It's not just writing the disk. It's not just being able to recover. You want to be able to recover. You don't want to sit down there and try to recover the data to a new shard because that's going to take a long time. So you want to be able to do it seamlessly. So that's the reason why you have something called a slave. A slave, you're always replicating the data from the master slave. How many do you use this concept at all? Master slave? Yes. So I'm going to ask you, if you don't mind, I'm going to pick on you. Right? Please. So typically, how many configuration files do you have, depending on the shards?
Off the top of my head.
For every shard, you have a configuration file. That's a challenge, right? When you have 3, you have 6, you have 9, and you're scaling. You can still manage, right? You can still manage your standard port. You say this is where it is. There's a slave off, blah blah blah. But the challenge is, again, that's one of the changes we have made. The challenge is when you start to exceed that. How do you manage all this stuff? How do you make it easier? How do you make it administratively simple? So from an enterprise standpoint, so that's another issue we have solved. But coming back to this, you're able to have multiple slaves, you're able to write all the data here. The challenge is if you're still doing persistent, it's still going to happen. So here's the other problem, right? It's now writing to a slave, and if you have, let's say, 1 million writes, what I'm talking about, it's writing to 2 slaves, and then you start to persist. Imagine the overhead is happening, and it's going to affect your performance. So always keep in mind when you're actually planning this, how you want to do it. You cannot have a slave of a slave of a slave. This is another thing we can talk about. But that is one thing. The second thing is when you're trying to scale this, so when you're trying to scale this, the best way to scale obviously is to start splitting your database. Partition the database, very multiple shards, depending on how you want to do it. You can use a hash shard. In our case, we also give you the option to actually define it based on regex. So you can split the data across multiple shards so that you can start to store data across multiple shards. As long as you know, am I making sense or I've lost you guys? Okay. So the moment you have, the more number of shards you have, the better your performance. So think of it this way, right? Each one will start, and remember, Redis is a single thread. So you could have a 16-core box with a single instance of Redis, it's still using only 1 core. So you're not effectively using the box at all, right? Maybe you're using all the memory, but you're not actually effectively using all the threads or all the cores from that box. So once you start to split this, now you have given it the ability to start using multiple cores if you want, right? So that's part one. The other part, does that answer your question on scalability?
Yeah, kind of. Is that something that we can like increase or reduce dynamically?
The new clustering? No, I don't believe so. But with what we do, yes. With the wrapper that we have, the enterprise use.
Okay, out of the box.
Yeah.
A challenge I'm typically having with setting up an infrastructure like this to support the ability to facilitate migrations of schemas.
Right.
And that's the hardest thing that I'm currently dealing with sure, like one of the benefits is not having a schema up front, but then how do you manage that? How do you manage the data? And how do you migrate that over time, like with setting up a cluster?
You asking me that question?
I'm asking.
So one of the biggest challenges is that people have that, right? Migrating the data. Here's the thing though. A lot of customers that I've seen were still using the pre-cluster days. Cluster has just been released like 5 months ago. Right? So it was relatively easier to write an app and then say, oh, you can get into these clients that would actually help you distribute across multiple shards. And take the data, convert it based on what you want, you can put it across multiple shards. Right?
I guess the follow-up question is, are there any other, I guess, best practices in designing schemas to be more in, like,
The power of Redis is
Yeah.
that not having to do that, right? You just go to that. I haven't had anybody, when you say schema, designing schema, what do you mean?
well, designing,
Schemas, right?
yeah, well, I guess that would be.
How your data should be stored.
Yeah.
So generally, in a relational database, you have the concept of a schema, which means essentially your data model. You got tables, you got primary keys, foreign keys, how they relate to each other. So when you move into a NoSQL database, specifically talking about Redis in this case, you don't really think about it in terms of a schema. What you need to think, what you're working with is keys and values. So all your data is stored in memory and is addressable by a key.
So
But you may want to come up with a key naming or key management strategy. How are we going to name the keys so you can search and find them, things like that?
So I guess to rephrase the question is not necessarily, I'm not necessarily considering schema, it's more so on the, how do I ask it questions? So like, retrieve it based on off queries. So how do I model, I guess, the keys in order for it to migrate from one key structure to another, I guess that's.
It's really about access patterns. So if you think
Access
about
patterns.
your application, what is your application going to need?
Yeah.
So I'll give you a perfect example. One of the things, I worked at an online gaming one time when we had, high scores. This is a very popular use of Redis because it has the ability to pre-sort data and whatnot. So we had the need for every game that we had a list of high scores, and every player had their personal list of high scores for different games. So depending on what you're looking for, let's say if we pull up a game and we want the top 10 players for that game, we'd have a key for the game ID with a set of here's all the high scores. But if we wanted to look, if a player wanted to look at his own profile page, he would hit a different key just for the user ID and pull up all of his personal high scores to display on the page. So it really comes down to what is the access that you need for your application, and those are what you're going to use for keys. The trick is just coming up with the right naming convention so that way your seeks and your finds are very quick. You don't have to sort through data unnecessarily.
That's where we're going to access the patterns.
Yeah, so and I think we cover this a little bit later about different types of keys. Well, I mean, there's really only one type of key, but there's things like you can do like key hashing, so you can take multiple values, combine into a single key, into a single hash, things like that. So there's a couple strategies like that that you'll see.
Okay.
Is there convention strategy
It
to
depends on the use case.
create that labeling pattern?
Yeah, so the labeling, the keys, you can name it whatever you want. I mean, it's literally a string. And what you could do is you could break it down by like colons. So you can say user : 1 : Bob, name equals whatever. So you can name it, you can put whatever you want in the string as long as your application knows to put it back together to go find it in memory. So you can put whatever you want as the key. Redis doesn't care about that because it's just going to take that and hash it to a memory address to find it in memory. That's all it's doing.
Okay.
And you just have to be careful what data type you're using. So there is a computation time for each one, right? You have, let's say leaderboard, right? You have millions of users. You may want to, you don't want to put it in a regular set or anything like that. You may want to put it in a hash, which is much faster than this one, right? The certain things that you could do, again, it depends on the use case that you're trying to solve, how you're going to translate certain things that you already have in your regular database to what keys you want. And the other thing is, there's no concept of, so to this point, right, you had the leaderboard, you had the top 10 scores, and maybe that you may have to create a separate key value store for that, just for your personal. For a user, you're going to have a user, score 1, score 2, score 3, score 4. User 2, score 1 to score 10. It's got nothing to do with the top 10 for the entire system, right? So you're duplicating data, basically, right? But that's part of what you do with Redis. We don't have the referential integrity to do it. Question? Any other questions? So Redis clustering, well, we're talking about scalability and Redis clustering. So this is the advantage of Redis clustering is if something were to happen to a master, right? The advantage is that today you may actually have to promote the slave, say that, okay, this is where I want to point my application, start talking to this new slave turned master, right? In this case, the idea is that if the master fails, the slave has to take over automatically and promote itself to be a master and start servicing the request. That's the idea. So depending on how you distribute the shards, and in this case, what I have is 0 to 5 and 0 to 5. So the master is here, the slave is here. And the master is here, the slave is here. And I've got multiple slaves in this case. So if something fails, the idea is the master here, the slave here should automatically take over and start serving the request for those shards. Again, this, has anybody played with the clustering, open source clustering yet? It's actually pretty cool. So these are some of the things that you're already doing. You're doing user session management, top use cases, leaderboards, finding friends, Facebook, Twitter, whatever, right? Message brokers, you're already using that. Listing, career builder, maybe classified ads, anything like that. Some of the more use cases we have seen, like on the DevOps side, is besides managing background jobs, is people actually bringing in a lot of config files, right? Config files and storing the configuration files. When was the last configured with the change management system? The other one was performing real-time analytics, bringing in all the event logs the last day or so, perform real-time analytics, try to coordinate the events, and then get rid of the data. So some of the things we've been saying is that. Question? So there are different data types. I'll just touch them briefly. Yeah, go.
Is your naming convention leading you somehow to relate to a relational type of thing at some point? Depending on
What is the
relational labeling of your structure or whatever, leading you to create internally this type of a system to figure it out. So you will be end up like playing with your variables internally to try to create a relation between your data points, right?
You're generally not looking to create relations for your data points. So the whole purpose of this is to have your data already laid out and like ready to access.
Okay.
Right. So
there's no
you can find relations.
right. There's really no association from one piece of data to the other,
Okay.
other than potentially you could wrap multiple values under the same key, which you'll see in
Well, you can also define relation, except that it's not automatically checking the integrity.
Yeah.
What you can say is, I have this country, blah, 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 right? What name, maybe the department is working, blah, 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 like you learn in a database. And then I could have something like user ID and something else. But every time you update the first one, it's not checking the reflection integrity. You need to make sure you update the second one too. That's like defining an index. If you have or an integrity,
You have to move that logic
that's
up
up to you.
with the
It's not
application.
going to do it perfect.
Yeah.
It's not like I do an update here and it's
Yeah.
actually checking,
Pretty much like,
accordingly,
yeah.
making sure it exists. None of that exists. No.
Okay.
Some of the, so I'm just going to cover a little bit about the data type. I'm not going to go in depth, but I'll just talk about it. You can actually go to redis.io, read up on this. It's a much better documentation. Okay, the strings are the most basic data types, the binary safe. You can actually have all these different functions depending on if you want to store the value as a string, if you want to store the value as an integer, this is what you can do. If you have floats, this is what you can do. If you want to store the bit 0 or 1, you can do that. Some of the examples here is this, again, shopping cart example, or you can do session management. You can replace that with session management also. This is how you do it. You do not have to, my idea here is not to actually show you how to code. This is a very basic symbol. I'm sure you have done this basically more than I did. But the idea here is how simply you can just make a call and define an entire database or perform an operation on a database. Think of it this way. If you have to do anything else, just the same thing where I'm pushing this into, let's say, a list. I'm putting a user, this is the key, and these are the value, this is the value, key, value. As an example, I'm just saying, this user ID, view this product, right? One line, one command. If you have to do this, what do you need to do with a regular database or something else? Imagine the time you spend, right? Same thing, if I have to get this out, this is what I'm looking at. And if I want, so this is another example, I don't know if you have this use case, but a lot of e-commerce companies have this use case, is I want to be able to see what a certain user did on what page, right? So you have a sequence of pages, and when I was working in security, this was a very common question people would ask. I wanted to be able to track if this user looked at page 1, page 2, and maybe jump to page 5, right? Because that would maybe, from an e-commerce standpoint, that would give them an idea as to what this user likes, what this user doesn't like, or how much time you spend on each page. Very simple. I just put that here and retrieve that. I can say, okay, give me a range between 0 and 9, what pages did you look at? Right? Simple command. I don't have to spend too much time writing queries.
Question for you on things like those lists. What if they, I guess, there's some practical patterns as far as the scale of lists that are appropriate. I mean, I'm using, I was using some sets, but you know, sets, you can't have repeated items, so that's something, but with a list, how much can I push into, list in a certain,
How much data?
how much do I, well, that's what I'm wondering, is like, how much is appropriate? Is it stupid to put in, put in hundreds or thousands of?
Hundreds and thousands should be fine, but when you're talking about millions, then your performance may affect because of the way the computation takes for lists, then try the hashes.
So as long as we're in the megabytes range, then we're cool.
Yeah.
Okay.
Yeah, remember, memory access is so lightning fast.
Yeah.
It's not even the memory access that's the challenge, it's the computational access to walk through it to go find, I want to know page 184 out of
Right.
10,000. And maybe at the end, you don't know where it is.
Sequential access, yeah.
So,
But,
Are things like lists stored, are things like lists, I guess, re-indexed and stored sequentially, like they are, like something,
it's going to access, no, it's not secret about, it's going to access and read the whole thing, like I was saying, right? You have to go through the whole thing. So the larger it gets, the longer it's going to take you. But if you don't care about, again, you're not talking about 1 seconds of latency, you're talking about a few milliseconds of latency. But you can get a measured performance with the hash.
and it's usually the one operation is not the problem. It's that same operation
Yeah.
at scale. When you're doing that same operation hundreds of times a second, thousands of times a second. So when you start to get that same operation over and over again, all at the same time, that's when you start to see the, what the real effects are. So usually the best case is, there's no rule, there's no guideline, it's whatever works for your system. You take your use case and you test it. You load test it, you see how it behaves. So you got to adjust it, you adjust it.
Just to add to that, thanks for bringing that up. What also matters is what kind of an operations, the transactions per second you want, and what kind of latency are you willing to live with, right? Based on what you're using today, and you see that you run the performance, it's all acceptable, then you're fine. But if you're going into gigs, I'm sure you're not going to be happy with the latency of that.
Right. Thank you.
This is the caching calls to the DB, and this is one of the things that we've seen customers actually like and have started using it. This is something like modification information. So one of the things with e-commerce website is either you go check the validity of the user if they're not doing it in the application layer, or you're going to go back once in a while and check the validity of the user of the application. You actually go back to the database and retrieve the details for that user, right? So that you can keep track of what that person is doing. So one of the things customers have done is basically store all that information in Redis, make that call, bring that as soon as the user logs in, they just get it from Redis and serve that data, or keep that session, keep that information, or track that information in Redis, or track that information in application. So if you want to expire this on a periodic basis so that Redis can go back and take that information, you can set up a time to live so that you can expire that data from the Redis database. You have a question?
Good for now.
Okay. No, you're thinking
Yeah.
seriously, so I thought, okay, maybe you have a question.
Yes,
Again, this is more, have you thought about this at all? I mean, from a Redis, any e-com, financial websites, anything that you guys do?
e-commerce mostly.
Back in database or in Redis?
In Redis.
Okay.
Yeah, for dashboards and we use Gecko boards that type it over.
You persist it?
Not necessarily, no.
It is good for rapid collection. Like if
Yeah.
you want to just capture data and store it somewhere temporarily until you aggregate it to move that off someplace else. But this is a great first point of entry for doing like metering.
Okay.
Like if you're doing like click tracking, things
Yeah.
like that. So you
Yeah.
capture it all there, and then a separate process, out of line of, whatever the user's doing up front, you have something separate that aggregates it, rolls it up, and then takes the roll-up data, stuffs it someplace else, and then you can expire it out of the cache. So let's say if you have like a lot of visitors hitting a website.
Yeah.
Yeah, so it's kind of like, where Google Analytics, if you think that stuff's going straight to a database, there's no way
No.
at that volume. So it's going into some kind of capture mechanism where it's temporarily persisted until they move it off someplace else. And it's going to be something similar to, I don't know what they're doing under Google Analytics, but it's going to be some kind of caching, it's going to be something like that.
For something like that, where you're talking about, using Redis as an intermediary store, what will then be, aggregated and worked on? I mean, is it that much faster than other storage engines like Cassandra?
Yes,
Really? Okay.
yes.
I'll ask the stories in the
High volume write. Of course, you're
high volume write, high volume read, both of them. I'll actually show you the statistic connected to this.
excellent.
It is sick fast.
I wish I had the other one, but we have the actual statistics with the same
But to give you an idea, I was actually doing some of my own testing and benchmarking of loading data into Redis.
Yeah.
And I was actually swapping the CPU on my client long before I did anything to the server. So I ended up having to spin up like 12 clients before I even actually got like a CPU tick on the server.
What type of memory do you assign your nodes? Like, how much memory do you assign to it?
Well, this is just one server. I think it was just 4 gigs of RAM, and all I wanted to do is get a transaction rate. How many puts per second can I do? And I had set up like a bash script on one Linux machine that literally just did a for loop and put like key 1, key 2, key 3, just loop. And just so I can get a rate. And the bash was actually consuming CPU on the client long before I even hit any sort of threshold on the server. So, and this was in Amazon, so what I did was I just spun up like 4 or 8 of these clients to all do it at the same time. And I was swamping out the clients long before, because the Redis was literally just capturing it and sticking it in memory. There was really no CPU work at all. So it was the clients looping, which actually consumed more memory than Redis storing the data. So I was actually having trouble actually reaching any sort of threshold on Redis to actually even hurt it.
What if you weren't using Bash, using something that actually didn't suck?
No, that's a fair question. Bash has got a lot of overhead, and I've hit a lot of issues with that. I would fork and say, well, give me 10 bash runs per machine, and I would just kill the machine. So if you did something a little bit more lightweight, like if you wrote it in Python or something like that, where it's less overhead, probably would. I mean, if I didn't take the time, but at the moment I was like, whatever, I'm done. So I just shut it all down.
Scale is.
Yeah, but there's no issue with it. I worked at a company where we had, I was talking about it was an online gaming company. We were storing high scores, and we had 150,000 concurrent users on the website at any given time. And a lot of them, not all the games had high scores, but a lot of them did, and people playing games all the time. Even if it wasn't a high score on the game leaderboard, it was their personal high score, and we stored that in their profile. So this large volume of writes and reads all the time across 600 games, 2 physical data centers, and I think we had a total of maybe 6 Redis servers. It was that good for what we were doing for our high scores.
So you can actually use Redis benchmark as a little to actually simulate that. And we also developed our own benchmark tool, which is also available on GitHub. It's called Memphier benchmark. So you can define how many clients you want to simulate the traffic with and how many threads you want to split per client. So that should give you a pretty good stress test on the Redis box. Hopefully, if I have time, I'll have to show that kind of hands on the floor. The other one, use cases are already calls to the DB, and again, like I mentioned in the beginning, there are 2 ways you can use Redis. One is maybe as an intermediate for your backend databases, or in some cases you can even replace it. In this case, maybe it's actually using it for system of records. So this is again a very simple. This is a small example of our shopping cart. You're storing this is the key, these are the values, the session ID, the product, and how many the quantity for the product. And basically, this is what we are doing, and then at the end of the call, at the end of the transaction, let's say he does a checkout, we're basically retrieving a simple HTTP call. That's it. And it's extremely fast. You're not bothering your application, you're not overloading your application, you're not sending the data all the way back to the backend database till he actually does a checkout. Once he does a checkout, you're storing for whatever purposes, you can actually store what are the different things you bought in the recent past, right? Again, that's just a hypothetical scenario. Questions?
Why do you use a hash rather than just typical string storage? Or
If you have a large amount of data, hash is much easier, simpler, and easy to maintain.
are string hash the only?
So these are the most commonly used. You have the sets, you have the list. And depending on the use case, you can
Like
apply.
core serialization types, you know? So, I mean, everything I've done has been basically serialized to string. Does it also, are there other ways, other things?
Yes,
you can-
yeah.
I mean, there's base hash.
Yes, yes, yeah, pretty much. But the way you have to look at the go register item, each command will tell you the confidential time. If you use a string, if you use a list, and depending on how much data you have, again, you could do the same thing. Whatever I did with list, I could do it with a hash, depending on the situation. I won't do that all the time, but that's also something you have to keep. The hash data that we were just talking about. So again, this is the most common thing used. I'm sure all the different examples we just talked about mostly done actually is actually, right? In this case, if I have to store, this is what Andrew was referring to a little while ago. It's much easier to retrieve the key. It's much easier to update the key when I'm storing it in hashes. It's like, think of it like columns in a table, right? It's literally that way, right? Here I have the key, user 1, user 2, user 3, user 1, all these things, user 2, all these things, user 3, all these things, right? So it's very simple for me to say, give me everything that relates to user 1. That's it. And it gives me all the details. So this, I can have each, this is a key, this is a key, this is a key, this is a key. In this case, I have only one key, user 1, and so all the information. Either one works fine. In this case, I can retrieve each key. I don't have to worry about it. And I'm here, if I retrieve the user 1 key, it gives me all the details. Does that make sense? Yeah.
No, well, I mean, that's a key that or using hash is more like, because I would want to always store, I've always stored my keys in that initial format on the left.
This one.
Yes.
Yeah.
And
This is the most common way, but if you want to aggregate it and store it this
which
way.
is usually what I
The
have.
disadvantage here is, the thing is, if I want to change, I have to retrieve this whole thing as user 1, then make a change for a certain value and basically rewrite the whole thing.
Yeah.
Here I can just do user 1 F name and just change, oh, somebody got married last name. I just change user 1 last name and then just change that back. Question to think about. Is this colon really necessary? Doesn't mean no.
No.
But most examples always have a colon there.
No.
It's to a point where people start to think, okay, that is part of the syntax, right?
No, it's just really for the people programming
Good
it.
notion.
So it's logic, it's a convention, so you can keep track of it yourself. Because user 1, is that really their ID, or is that their name, or is that one ID, or is that one F name, 2 F name? Yeah, so it's just a convention, just so you can keep track of it yourself. It's like the comments you put in your code.
User 1 is not user 1. User 1 is a label. 32 character.
Yeah.
Hexadecimal value.
It's like comments in your code. Do you really need them to run the program? No. It's for you to look at it 6 months later and you go, what the hell did I do? So it's really just so you can look at it so you know really, the programmer knows what that is.
I think either you or you had this question about storing like a referential integrity, right, in a different table. It just happened to me. In this case, let's say I would have user 1 ID and email, and maybe store other details of what they're doing. Another hash or set, maybe I would have user 1 first name, last name. But every time you have to make a reference or bring the data back, you have to refer to both, and there's no validation. It's not going to say, okay, is this null or not, or anything like that. That's something you have to check. So you can do that. That's
Well, I mean, that was, this could solve a lot of issues with keeping data in sync, which I ran into some troubles early on.
Yep.
In terms of like just, all right, we're working on a new feature, we're asking the database different questions. But a lot of the assumptions were based off of data in another like column or in another like key structure. So that way, you had to basically import that data into this new column, and then now we were able to get that accurate answer. So that's kind of, we definitely solve that.
so everything you use is hash. Okay. Again, denormalization, I think Andrew was referring to this again. You don't have the concept of referential integrity in Redis. Right? That's something you have to maintain, and that's part of the reason why it's so fast. That's the trade-off. You have to just live with it. Maybe in some cases you'll have duplicate data, and you will. In some cases, most of the time you will have duplicate data. That goes without saying. By the way, I used to like Japanese. I don't like them. Why not? He's just too old now. He doesn't act anymore.
Could be helped.
He doesn't act anymore. And his wife is sitting by the Lakers too much. Which is again my favorite team, so I know people who hate me here, but
Does Redis use its
I know.
own, does it use its own from the ground up storage engine, or is there another storage, or does it rely on a different storage engine? There's a lot of things at this point rely on like DB. But Redis is
doesn't rely on anything. It's
completely
doing
independent.
Yes.
Okay, cool.
So one thing that's cool though, is that Redis does interact with the, you can interact with Redis using Memcache protocol. So if you already have an application that's using Memcache, just point it to Redis and it'll work. Because it understands Memcache protocol. So you can treat it like Memcache, but it's got a lot more capabilities than Memcache, because Memcache doesn't have the variety of data types and operations that Redis will.
That's what we're store the application.
Yeah.
Convert it from MySQL to Redis.
Yeah.
So it's quite interesting.
Yeah, and that's it.
Yeah.
No, if you want to time, want to check. The question is, can you have duplicate keys?
Well, you're saying you have duplicate data before you're.
Duplicate data, yeah, duplicate data, the values are different. I have duplicate values, but I can't have duplicate keys.
Okay.
So, in this example, I can't have user one ID one, and I cannot have another user one ID one again, right? I mean, I cannot define this twice, it's already defined.
Right.
The key user one ID.
So if
So it's not really a problem, I mean, if you keep that.
That's
It's that extra.
If your
Use a
naming
little bit more
convention,
memory.
sorry, if your naming convention is poor, you will be overwriting pretty much. a
Yeah,
bunch of
that's,
that.
that's sort of the convention that,
Yeah.
it's really a strategy of how you're gonna define your key strategy.
Yeah.
So that way, if your application is aware of what the key convention is, then it doesn't override its own data.
Yeah.
Yeah, you obviously don't want every key to be user. You're gonna be overriding everybody's
It
data.
depends on how you store it, but that's part of the reason why, that's the reason why it's so fast. Okay. So this is another list command, basically we're using to scan a specific, so in this case, in the last example, we defined users, right? A list of all the users, for example. So if I have to go back and do this with a database, I have to do select star from blah 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 with certain condition or whatever. So and then that's the query. With Redis, again, forget about all this as basic code. All you need to do is I'm actually getting this data using the Redis scan and just getting all the user data, and then I can do whatever I want with that in my application. Again, the idea is the simplicity, right? All you do is you have so many commands, you just need to know what to use and get all the data. Some commands are not good though. Especially if you have a 2 gig database and you go there and do a keys command, it's going to goes up your database. Or don't do flush DB, right? We were talking about it last night.
Yeah, FlushDB is particularly nasty. That basically, FlushDB is exactly what it sounds like. Your data is gone. Gone. There is ways to protect against that. You can actually mask those destructive type commands. There's a config file where you can rename so FlushDB, even if the programmer knows that command exists, they may try it. but you've renamed it to something else. And what I've done in the past is I just generate random hash values and I rename FlushDB to that random hash value. Nobody can ever guess it. So no one's going to accidentally flush all the data.
It's not that it's useful also, I mean, especially if you're just using it for cache, something that you have to, update every few days. Maybe the first command in your application will be just flush everything. That's useful, and then, but system of records, once you start storing data, that's something you want to stay away from.
And it's really fast. Your data will disappear very quickly.
Just as it got created, right? As fast as it got created.
Yes.
So these are other cool things. I thought, this will be very helpful if you want to play with it. These are something like we have learned. If you look at, how many of you work with SQL queries?
What?
I assume. Okay, think about how you did outer joins, inner joins, right? Intersection. How long are those queries? Right? It's like literally, it's like bare minimum. Let's not talk about simple queries. Talking about complex one, it's like 15, 20 lines. You do select blah, 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 where blah, 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 in, again, select blah, 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 right? Whatever. So here it's very simple. In this case, if I want to do an intersection, I want to know between those two users who their common friends are. This is it. I do an S enter, it'll give me the common friends for both the users.
The node name.
Huh?
Like the node in a graph database.
Yes. This is the difference for the mutually exclusive friends. All I need to do is do SDiff. I have, right away, I've saved 20 lines of code. Think about it. Right? And again, you don't have to worry about the performance also. You know that this is optimized, this is running on the server, it's all optimized. You don't have to check your SQL queries, figure out, okay, is this totally optimized, are there different ways? Because every single query we can write it 10 different ways. Not everyone is optimized.
And performance-wise, what do you think about in comparison with graph database asking for like weird combinations of data?
Sorry, the last one you said graph database?
Yeah.
My fault. Redis is not a graph database.
Yeah, I know, but benchmarking like two solutions because this is pretty much.
You have the a geolocation data type. Geolocation data type where you can start to store all the coordinates in Redis.
Yeah, he was talking about specifically graphing database like a Neo4j or an OrientDB, which you can, you can mock the concepts, right? So what you've got there is you've got user one friends and their list of friends. Now I can have user 4 friends and put user 1 in it now that they're friends. So now I can start doing this association. What you're missing here that you find in a graph database is not only can, in a graph database you can add attributes to the nodes, but you can add attributes to the relationships, and then you can do sort of this recursive walk from node to node to node until you run out of nodes. But here that's not something you get here. This is literally just an array, and you compare them. It's just done it much faster. So it's different access patterns for different needs. Okay. Yeah.
Sorry, I don't know graph database.
No worries.
It's not possible to know everything. Again, I'm going to skip all of this. I just want to show you a quick. I didn't cover all the commands. You have so much more here. Let me just quickly show you how the performance is on standard Redis. Okay, I'm going to run an emptier benchmark, simulate some clients, connect, and you can actually see how many operations per second it generates. Okay, this is basic. The more performance you want, the more sharding you can do. It's as simple as that. All right. Oh, one last one. Here. This is what I think we're talking about. So this is a performance benchmark that was done by Avalon Consulting. Basically, they compared Couchbase standard, Redis Stack, Spike, and Redis database, and they compared how many requests per second were addressed. What was the latency? So if you look at Cassandra, the latency for, in fact, after 5,000 was a problem, but latency for 35,000 requests was about 381 seconds, milliseconds. Here, 27. So huge difference in terms of how we are addressing the data with Redis. By the way, to deliver 1 million operations per second for Cassandra, you need about 300 servers. With Redis, just 2. Again, this is independent consulting benchmarking company. It's nothing to do with, nobody from Redis did that, nobody from Redis Labs did this. Some problem in terms of speed. Keep on speed. Questions, anybody?
What's the average profile of a machine that you assign for Redis cluster or just a Redis box? For example, how much memory do you assign it?
Depends on what your use case is. We have had customers use it on a 4 gig because the data set size is only 1 gig.
Yeah.
But they've sharded like three times, if you will, within that 1 gig because it's just splitting the data. But usually like 3 or 4 cores, depends on what you want. We have customers using 100 node clusters.
In general, if you're running one instance of Redis, all you really need is 1 core and enough memory to hold your data.
So it's good, to rephrase that question, say I have a 20 gig data set, how would I,
You need 20 gigs of memory and 1 core.
So
Unless you want to split that,
Yeah.
you can say, I want to split it into 8 gigabyte shards.
Yeah.
So now what you got is you got 3 instances of Redis running on the machine on 3 different ports. And you give each one of them a section of the data. But your application has to be aware, do I go after Redis 1, Redis 2, or Redis 3? Because each Redis instance uses 1 core. So somewhere in there, your application has to know, or you can put it behind the load balancer, depending on if you're reading. If you're reading, fine, put it behind the load balancer if they're all equal. If all the shards are equal, then you're splitting the workload and you're just getting the use of multi-core. But if you actually have segregated data, then the application has to be aware of which shard the data is in. Unless you had something like Redis Cluster or Redis Labs, which handles that for you, then you just point to one endpoint.
Now,
Yeah.
Redis Cluster does handle, addressing it, so you address the data, you address it as a whole rather than having to address
Yeah.
individual shards, right?
It abstracts the endpoint away for you.
But 2 ways you can do it, right now, before I get there, but yeah. So 2 other things, in addition to what we said, you have to consider is what kind of performance you want, right, from a transactions perspective. Because if you have a single database with single core, what kind of transactions? And with that comes your latency, right? What are you willing to live with, right? Are you willing to live with maybe 5 millisecond latency, or do you want a 7 millisecond latency?
And so is there a correlation with latency versus the amount of space I'm assigning to Redis server versus in addition to how much capacity my data set is going to contain?
It's not the size, there's no correlation between latency and the data set size, but there's a correlation between how you want to split your data across multiple, right? Say for example, if I want just some millisecond, right? It's easier for Redis, I'm taking advantage of multiple cores and actually accessing the data and getting it back. So I can reduce the amount of time it actually takes for the core to process to a single shard and get it back, right? So, but if you say, yeah, I'm fine with 1 millisecond, right? And again, that difference is not huge unless you're talking about multiple gigs of data, right? If you're talking about 5 gig and 20 gig, the difference is not huge. I'm just giving you an example.
Okay.
That's something, if you're looking at financial companies, right, they are looking at some like 0.01. I cannot afford more than that downtime, right? So just keep that in mind also, what you're willing to live with, what is acceptable to you when you're deciding the number of shards. Data set size is fine, 20 gig, 30 gig.
So the only thing that I can think of where that might come into play, right? So your key that you give it gets hashed to a memory address. So as long as you got unique keys, that retrieving that one known key is going to be super fast. It doesn't matter if you have 20 gigs or 20 terabytes. But if you're doing any kind of operations that you're scanning a wild card, let's say all your keys are user 1, 2, 3, 4, 5, user 1, 2, 3, 4, 6, and you search across user star, it has to search all of those. So those operations, the size of your data set, or depending on how you've got your key set up, your key naming convention, that might impact it. But that's a very edge use case. Most of the time you're going after a specific key.
Okay.
Can you talk a little bit about the ETL and expirations?
What was the question?
Sorry.
I want to know more about ETL and expirations on, where can you only do time to live or expiring data on have a key that expires the value, or can that be an item in a set, or is it set as a whole?
For anything that you create, you can have BTO.
Every key, and one of the attributes is a TTL, and by default it's set to forever. So you can go in there and change the TTL and give it 3 seconds, 1 second, 0 seconds, which means it immediately expires. You can set it to whatever you want.
And is that true for items in a list?
No, it's the key.
So that's
It's
the-
on the key.
Yeah.
So the key is the expiration. So you have a key with 1,000 items and the key expires, it's all gone. You cannot set a TTL on one element in an array or one item on the list. It's at the key level.
Nice.
Yeah, it's a key driven. Doesn't matter what data type you use.
Right.
It could be list, sort, whatever, but it's a key driven. And not the, so, yeah, not the data type, not the data, just the key.
Are things like lists, and I guess I kind of asked this before, that, our lists, list items stored sequentially, and I guess in memory it doesn't really matter, but when you persist it, is when you persist, are list items dealt with that way, are they dealt with sequentially, or it doesn't care?
It doesn't care, whatever you have in the memory system is basically right.
Okay.
It's not setting anything in a special way or.
So then with list items, are list items dealt with as their own? I mean, is the list dealt, considered a value as a whole, or are the list items their own, individual values and an index to them in terms of storage?
So the key helps you find it in memory. Once it grabs that section of memory, Redis is smart enough to know, based on whatever data type it is, there are certain operations available. So if you have 10 items in a list, you don't even have to delimit them. There is no delimiter needed because it already handles that for you. You don't have to make it comma separate. You can if you want. Take a string and put comma separated in there if you wanted. You can put JSON in there. It doesn't matter. You can even just have a list of images and actually put binary in each element. That's completely up to you. Redis will track each of those elements. You don't need a delimiter. It does it for you. But it will treat the whole thing. The value is, so it's the key and the value. The value can be any different data, multiple data types. So the list is one of them.
So the list is the value.
The whole list is the value, but you can iterate over that list. You can grab that list and tell Redis to do something for you. The alternative is you got to pull the whole value back and do that operation in the application. But since Redis has it at the Redis level, you can tell Redis, give me element 3.
Right.
Or just search the whole thing and tell me what position this value is. And it'll go through the whole list and say, oh, this is, in the array, this is position 4. And it'll come back and tell you that.
Inside the array,
Yeah.
on your value object.
So yeah, you say, go look at this, so I've got value 5. Is it even in the list? So you just say key 5, key 10, see if the value 5 is in there. And it'll search all the elements and come back and tell you.
Through your like nasty JSON, huge type of thing, and it's my
JSON is not a data type in Redis. You can store JSON as a string. So
And I can parse it.
so there's no matching operation for JSON. So that's the thing. There's data types and then the operations on the data types.
Okay.
You can store JSON as a string, but you can only do string operations against it. So you can pull that back as a string, you can ask the length of it, you can ask for a substring, you can ask, is this character in it? But if you want to say, give me just the name field, that's not going to happen.
Okay.
If you want to do something like that, you'd store it in a hash table. You'd store it in like a hash aggregation, and you pull out
That's
this field.
fields,
Yeah.
separately.
Yeah, cool.
I just want to show you some performance.
Before you really pick off the performance stuff, can you zoom in? When do you get there?
And that's
Yeah, here we go.
two windows. Do you guys see this?
No, you got to zoom in a bunch. I'm not just advocating for the old blind guys in the back.
Move up front, please.
You're gonna have to zoom in quite a bit.
No, it's actually in Amazon. I'm going to take Amazon right now.
Command plus. Oh, sorry.
No, this whole screen. I have to move it back here and increase the size more because I can't get the, some of the matches on that.
Maybe it'd be easier just move some camera closer.
Is that okay? It's still small. It's at the under the.
You're asking the wrong guy. I'm the old blind guy in the back. Can everybody see it? How about that? pretty good?
Yeah.
It's 150%, I can make it 200%.
Well, let's just proceed, and if there's any challenges, then we'll try it again.
So this is, again, I'm not here to talk about Redis Labs, but this is just our GUI interface. Just going to go ahead and create a database real quick here. So I'm creating a simple master database. I'm going to run a performance against this. That's something that we developed called Menti or benchmark. This should show you how fast this is. Basically, the kind of operations I'll be doing. And here, these are the metrics. Can you guys see this? Yes.
Nope.
No?
Nope. Can you zoom in?
Okay. Is there a zoom button?
Command plus, but that's not,
Command?
yeah, that's a Mac.
Yeah.
I don't know.
Yeah, no, I'm sorry.
Okay. Keep doing that again and again.
Yeah, how interesting. Yeah, you can talk us through it.
Okay, so this is just a basic Menti or benchmark. Again, by the way, I have my instances in Amazon. Okay, I have 2 instances running with Redis Labs. Again, with Redis Labs, our core is still Redis. We don't change the open source. That's the wrapper around it. So this is a Menti or benchmark. Again, you can use it for your Redis instances. It works. This is an open source, something that we have developed and posted on GitHub.
So it's just a command line utility, has a bunch of options.
It's like
Point
Redis
at your
benchmark,
database.
yes.
Go.
So here's how you connect. There's something called endpoint. This is what I'm doing. So with Redis Labs, when you create a database, you don't have to turn using an IP address or anything like that. You could have multiple shards, but continue to use just the endpoint as long as this is resolvable via DNS. This is a port. I'm doing a 1:4 operations for every write. I'm doing 4 reads. Okay. This is 2 threads and 25 clients. And just give you can play with those numbers, right?
So what do you get? What's your threshold that you're going to throw at it right now?
100 data size is 100 bytes with 25 clients and 2 threads.
100 bytes and what?
25 clients and 2
25
threads.
clients. So you're going to spin up 25 connections, hit the database.
50. So 25 times 2.
50. So 50
Each
clients.
client will have 2 threads, spin up, throw
Got
the
it.
data in.
All right.
Let me get something here. 1, 5, 2, 5, 2. Changes.
So you got 50 connections, and each connection is going to do what? It's going to send the data, how much to Redis?
So once again, 100 bytes.
Huh?
It's gonna run up to
It's going to write it once and read it back 4 times.
Oh, yeah. I forgot the port number, that's why I yeah, so it's very hard. So, but it does 4 read operations and 1 write operation.
Gotcha. So this should be crazy.
And recursive. Recursive.
Lucas, yeah.
So I'm running, what's happening is, I'm running this test 10 times.
Gotcha.
So multiple iterations, so
At
you
your
see
duration.
multiple inserts. Every time you're doing that, inserts with a different number.
Yep.
Right? So you can actually see this. You can switch back here and actually
Bam.
you can see the operations per second. So after done, this is a basic standard single shard, single master database. We're using just 1 core. I got about 0.67 milliseconds.
So what do we get again?
0.67 millisecond latency with about 750,000.
0.67
milliseconds.
0.67 milliseconds or 67 milliseconds?
0.67.
0.67, so less than 1 millisecond.
Yes.
Yeehaw.
With about 750,000 operations per second. So going back to your point, right, if I want to improve this performance, you can just go back here. Sorry. And I'm just going to start this. Again, if you're using open source, you have to create it at the command prompt and all that. With Redis Labs, you just go here, I'm gonna say create cluster, right? And update it. So it just finished it's actually creating that right now. Once it does that, by the way, that client doesn't get affected when it's doing it.
What happened? Sorry?
The client doesn't get disconnected when I'm creating shard or anything like that.
Interesting.
So it's completely transferred to the client.
So what you've done now is you've
Yes.
taken that data, sharded it.
No, it won't.
But in
No,
terms
no.
of performance,
Even the performance won't be affected. You can actually see this on the.
Is it like using separate cluster, like, and then swapping them out when it's ready, or?
Yeah. In the back.
That's, yeah.
Right, so you can actually see the latency immediately fell.
Yeah, it's improved because you're splitting it across the
1 PA,
two.
which is literally by half, right? And your performance has gone up to over 1 million transactions a second, about 30% increase. So again, that's why sharding becomes important if you want to. It's not just the size of the database, it's what you're looking for. How many operations do you actually want to perform? And when you perform this, what kind of a latency are you willing to live with? That's going to drive your architecture for Redis. Again, that's a very simple thing. I just wanted to show you this is how Redis works. Again, the hardware software is still Redis, open source, so this stands true for open source Redis.
Awesome, very cool.
We have all the statistics. Obviously, with Redis, you have all those statistics. Here to show you how many reads are happening, how many writes are happening, read latency, write latency, use memory, how much am I using, and the limit total number of keys, how many have been evicted, what's total incoming traffic, right? 54 MB, outgoing traffic, how much is happening. So all these different things. And persistence, you can define the same thing here. So here's the thing, right? When you define persistence with open source, it starts driving master. So when you're looking at this kind of performance, you start to define persistence, your performance will take a hit. You have to live with that. But again, that's the other improvement we made for enterprise environments is we start writing from slave so that your performance never takes it.
Where does this tool live?
The RBAC,
Yeah.
Redis Labs Enterprise Cluster, right over Redis. There we have Redis installed.
Right on top of it?
Yes. It's
You
just
install it.
it's just a wrap around the open source. That's all. And it's about 5 MB install.
Is it essentially the equivalent of a cluster manager?
Not much more than that.
Okay.
Because when you say just a cluster manager, for me, you're just managing a cluster, right? But the background work that goes behind how we actually try to keep up the performance when you're managing a cluster, make sure that it's easily scalable and make sure that it's highly available without affecting the performance. So it's just a little much more than
Okay.
regular cluster manager. Then it comes with a proxy, right? So that our own inbuilt proxy to keep track of all the different hosts within a cluster. It comes with our own DNS. So.
within your solution, there's an auto-scale feature?
Yes. Not for the, once you add a node, it will automatically start to scale. You will not add nodes, right?
Not automatically add nodes.
Yeah.
So if you add a node, it'll start using it, but
Yes.
it won't automatically add nodes for you.
Yeah.
Okay.
So physical host or virtual machine or an AWS instance, we don't do that. We don't add that, right? You need to add, or you can configure Amazon to spin up a new instance when you hit a certain threshold. You can call it API. Once you do that, once it becomes a part of the cluster, so here's the cool part, right? Obviously, I have 2 nodes here. If you see I have 2 nodes here, once it becomes joins here, the size of your database you can automatically increase. So let's say you're having a problem with the database without affecting the customer and clients, right? I don't have to restart, I don't have to reboot or anything. I just go here. You can make an API call also if you want, or you can distribute the shards accordingly. I can just go ahead and save this. That's it. My client is still running, it doesn't even affect the client.
Based on database size and also performance.
Yes. What do you mean?
If it gets too crowded, we can just create a node.
Yeah, absolutely. It doesn't affect, yeah, you can.
Okay.
Because again, it's a shared nothing architecture, so when you create a new database, it starts to use a new core. And Any other questions? No, it's coming, it's coming, it's coming. No, it's fine, if you have it.
There you go, something happened.
No,
That's just the next round.
Iteration.
Yeah, okay,
I've got 10 iterations, that's going to run for 10.
cool. Awesome.
Can you go back to the persistence on AOF specifically? Is that already like recommended? Like that's already?
Yeah, but people have been using it for a long time.
Yeah.
This is, again, you changed how it works behind the scenes, but with Redis Labs, for request. But it's still the same. This is the same thing. You still call them. You have the AOF, you have a snapshot, right? And this people have been using it for a long time. The worst case scenario, I prefer the AOF simply because you store all the data. The worst case scenario, you lose 1 second data. For the worst case scenario, the whole thing is gone. Your TR set is gone, wherever your replication, everything is gone. That means then you've just lost 1 second of data. But if you have replication, if you have additional slaves and all that, then you know.
So say for example, transactions are in the website, 100,000 transactions, and that's the load. And for whatever reason, because it's a simple process,
Oh, you mean in open source when you do web app?
Yeah.
If you're, that number is something you'll have to figure out because it changes every instant. There's no benchmark saying, hey, if you hit 100,000 transactions, it's going to affect the performance of it. No. Because it depends on the size of the database, it depends on how you store the data, it depends on what data types you're using, it depends on how many operations per second you have. However, with open source, when you start doing there will be a number, a certain number. Once you hit that, you're going to have a performance peak rate.
So is it easy to find that number? And
You have to run benchmarks.
benchmarks.
Yes, you have to run benchmarks to find out that.
So with AOF, can you go back into a specific point in time? Like, is it's keeping track of all of that?
Yes. No, actually no. So, that I don't know. I don't think you can go back to a specific point in time.
No.
Like revert to a.
It's writing all the rights.
Not natively, so basically you could potentially take one of the, whether it's a snapshot file, the RDB, or you can take the AOF and move it to another machine. You have to trick it, but you could bring it up and it'll instantiate the memory from that file. But you cannot do a point in time. You can't give it a time and say restore it as of 1 a.m. or whatever. It doesn't have that functionality.
So you'd have to like remove part of the file and then
Actually,
Yeah,
there's an easy
you
way.
can't really do that unless you get a binary editor. Good luck with that. But it's not native to it's not native to Redis.
Okay.
More than likely, you corrupt the file if you try that.
There's a better way of doing it. That's AOF. That's not the purpose of AOF.
Yeah.
AOF is supposed to persistence, like it's having your read log files in order. There's a better way of doing that. Just do an export of the database, right? You can do it every so often of the Redis database. So again, this will translate to whatever you have.
so that would be like more of the snapshot thing where you just
This is the entire database. Just take that, not snapshot, but the entire database. That's like Oracle export.
You can export that.
Right? You do it every so often, and then you can do the anomaly or snapshots. So if you want to increment it, right, you do a snapshot every 4 hours or every 6 hours. So have this, then you can import that. That's one way of doing it. Or else you can use the Redis itself to replicate to a slave and use that for whatever you want, right? Any other activity. So there are multiple ways, but definitely not just the other.
You would combine AOF with potentially a periodic backup, not necessarily the snapshot with periodic backup.
You can do both. We can say AOF plus periodic, snapshot plus periodic.
If you're going to do both, you just have to be very careful of the periodicity of how often you're writing RDB and AOF. Because the combination of the two, it's almost like you're constantly writing.
Yeah.
So you have to be very careful about, but if you space it out too far, then kind of what's the point? So you have to balance it out. Usually most people do one or the other depending on the use case, but you can do both if you want to, or you need to, it's depending on what your strategy is.
But I think in your case, you absolutely have to do it. It's your system.
Okay, so is there any relation between like comparing Sentinel, what it provides to Redis Labs? Does Redis Labs utilize Sentinel, or those two completely separate systems?
Completely separate.
And where do they overlap in terms of functionality?
Yeah. Once if you're using Redis Labs, you don't need Sentinel.
Okay.
You don't have to deploy certain nodes. This is it. This is how you manage availability and scalability of the Redis cluster. You don't have to use Sentinel, or you don't have to use Redis. But once the Redis cluster in open source is production ready, obviously it's just been released, people are still testing it, the word is still out. Once it's production ready, we'll start supporting it. Anything else?
Is that it? No more questions? Cool. Is there anything else for this presentation? Good? Awesome. Awesome, guys. Thank you so much for coming. Like I said, I really appreciate it. I know it's tough to make it down to Miami Beach with this kind of traffic on 7 o'clock in the middle of the week, so I really appreciate you guys coming out. Please go to meetup.com and rate the event. So the more stars we get, the more people we get signed up, and the more people we can get in here. It's really what it's about, is getting people coming in, sharing their knowledge, sharing their experience. So this is really great. We had a lot of engagement. Had a lot of engagement last night too. So between Fort Lauderdale and Miami Beach, this is a really good event. So thank you all for coming. Thanks again for Rocket Labs for hosting us. Thanks for Venture Tech for the support. And thanks obviously to Madhu and Devin.
Yep. And just one last thing, if anybody has anything else that they would like for speaking topics specific to Redis, feel free to shoot me an email, because I plan on bringing someone else from Redis who's his role is developer evangelist, and he's going to be going to East Coast and probably South Florida in the next couple of months. So any topics that you guys want to hear more about specific to Redis, let me know.
Cool. Awesome. Thanks, everybody. Appreciate you coming down. If there's any soda or pizza left, feel free to grab whatever you want.
You know that I'm